Okay, so in Module 4 we're focused solely on skinning, which is the way that we connect the character model to the skeleton, so that when the skeleton is rotated via the human IK rig, the rotation of those skeleton joints deforms the body in an anatomically correct manner. There are several ways to go about skinning a character in Maya. We're going to stick with classic skinning, the most basic way to skin a model to a skeleton, because I think it's important to understand skinning on its most basic level before you try to work with the newer approaches for skinning a character, which really don't change the way that the model is connected to the skeleton. There are simply newer ways to go about painting the skin weights. I'm going to stick strictly with classic skinning, where we're going to use a grayscale map to define how each joint should affect the area of the model that it's closest to. We're also not going to go over any muscle systems. Maya offers a way to attach NURBS models that represent the muscles in the body to the skin so that those muscles stretch and compress as the skeleton is rotated, and in turn those muscles deform the skin in a much more anatomically accurate way. If you want to experiment with muscle systems, feel free. I'll warn you, they're computationally expensive. Setting up an entire character with even a basic estimation of the major muscle groups in the body would severely tax your system. So if you do want to experiment with Maya's muscle system, I would suggest you set up a simple cylinder and a 3-joint chain and focus on experimenting with a basic bicep muscle that will stretch as the arm straightens and compress as the elbow bends, just to get a sense of how that will work. But for this project and this course, this tutorial, we're going to stick strictly with the basic grayscale map skinning. But before we get into the steps involved in skinning a character, and there's a fair number of steps that you have to undertake before you begin skinning, before you bind the model to the skeleton, so that you can then go about the process of painting the skin weights effectively and efficiently. I'm going to try to explain the basic way that skinning works, because I think if you can understand the basic relationship that you're setting up here, it'll be easier for you to troubleshoot any issues that you run into. So before I get into this, as I mentioned in an earlier tutorial, when you apply the human IK rig, it sets the draw style for a number of the joints in the skeleton to none as opposed to bone. So if I select any of the joints that we can see and go to the attribute editor, I can see that its draw style is set to bone. But if I arrow up here to the head joint, which you can't see, you can see that its draw style is set to none. So before I start skinning, I want to display all of my joints. So I'll just arrow up till I get to the hips joint, which is the root of the skeleton, go to my GRA 212 shelf, click the select down button, which will select all of the joints underneath that hips joint in the hierarchy. And then I'm going to open something called my attribute spreadsheet from my Windows General Editor's attribute spreadsheet. And this is essentially the way to access the attribute editor for multiple selections. So when you select any one object or element in your scene, you go to the attribute. When you select any one object or element or joint in your scene and you go to the attribute editor, you're seeing the settings for only that one joint. And if you select multiple objects or elements or joints in my case, you can see on the right here, I'm only seeing the very last joint that was selected, the joint at the very end of the right foot. In order to change the attributes of multiple selections, we have to use the attribute spreadsheet. So I'm just going to drag this so that it's larger for you to see. And I click on the All button and scroll all the way over to the right. I can see that I have this draw style column. So with all of the joints selected, I'll just click on the top of the column and type in bone. And that will set the draw style for all of the joints in the skeleton to bone. And now in my Human IK tab, I'm going to hide the display of both the IK and the FK, just so that it's a little bit clearer for you to see as I go through the steps. But in broad terms, the way that skinning works is that each vertex is assigned weights that, when added together, will always add up to 1 based on the joints that are close to that vertex. So this vertex here on the model, when I skin this vertex will be weighted partly to the left arm joint because it's going to deform when that left arm joint rotates down, the one at the shoulder, and partly to the last spine joint from which the arm chain extends, because when the spine rotates, this vertex is also going to be affected by the rotation of that spine joint. This vertex here is going to be weighted partly to the first neck joint, the second neck joint, and the joint at the base of the skull, the head joint. Because when the skeleton is posed, both of the neck joints will affect this vertex, and when the head is rotated, this vertex will also be affected as well. So this vertex might be weighted 0.25 to the first neck joint, 0.35 to the second neck joint, and 0.4 to the base of the skull. I just grabbed those numbers out of the ether, but it will be weighted to a number of joints. Sometimes it might be 2 joints, sometimes it might be 3 joints, sometimes it might even be 4 joints, but the combined values will always add up to 1. And that allows the model to deform by way of its vertices based on how close that vertex is to various joints in the skeleton when those joints are rotated. Those values from 0 to 1 can be described as a grayscale map, where 0 is black and 1 is white, and all the values between 0 and 1 are different shades of gray. So values closer to 1 will be lighter gray, and values closer to 0 will be darker gray. And that's essentially how basic skinning works. It assigns values to each vertex on the model based on the joints that are nearby that vertex, and those values are described as shades of gray, where 0 is black and 1 is white. But because skinning works with textures, grayscale textures, we need to make sure before we begin skinning that we have non-overlapping UVs on our model. You don't need non-overlapping UVs to skin the model, but you do need non-overlapping UVs in order to export the skin maps and re-import them. And that's very important because you may find at some point as you're working along here that the joints in the skeleton you set up for your character aren't placed correctly. You might have placed the left arm joint that rotates the shoulder. You might find you put it too far into the body or too far into the arm. And that's something that no matter how much time and care you spend painting these skin maps, they can't fix poorly placed joints. So if you found that you had this left arm joint placed incorrectly, you could fix the skeleton and not lose any of the skin weighting that you've already done by selecting your model, going to the skin menu, and exporting the weight maps. And what that will do is it will create a text file, and I can open that up in Notepad, that lists the name of the model, each joint involved in the bind, and we're not going to bind to every joint in our skeleton, and we'll go over why that is in a moment. But this weight map file simply lists the name of the model, each joint involved in the bind, and then a call to a texture map for each of those joints. And then in the same folder where you exported those skin maps, there will be one texture file for each joint involved in the bind that applies that grayscale map that defines the skin weights based on the UVs for the model. So in order to be able to export those maps, and that's important if you have to make changes to your skeleton and you don't want to lose the skin weighting work that you've already done, you need to have non-overlapping UVs. So my model already has non-overlapping UVs because I used this model for a project where I needed to texture it, so I already went through the process of setting those up. If this model hadn't already been mapped, you can very quickly achieve non-overlapping UVs by selecting the model, going to create automatic mapping, and that will separate the UVs on the model into shells that are non-overlapping. And I like to use the highest settings for less distortion, so I'll use 12 and less distortion, so I'll get more pieces, but I'll get less distortion in the maps. I'm not going to apply automatic mapping here because I've already set that up, but it's important that you establish non-overlapping UVs on your model before you start skinning. And you can check for those by selecting the model, going to the UV editor here, which is under the Window Modeling Editors UV Editor, right-clicking and choosing Faces, and then selecting the overlapping faces in the layout. And if there are any overlapping faces, they'll turn red. So you can check your model to see if it has any overlapping faces in the UV map, and if it does, you can fix them by applying that automatic mapping. And then once you've applied that UV mapping, you'll want to delete the history on your model, because when you skin it, you don't want the software to have to evaluate that UV mapping history when it applies the skinning. So once you've established non-overlapping UVs for your model, simply go to Edit, Delete by Type, and History. before you bind the skin so that there will be no existing history on the model when you begin that skinning process. So the reason I'm not going to bind to all of the joints in my skeleton is because A, the last joint in each chain has no effect. So I wouldn't want to select the last finger joints or the joints at the end of the toes or the joint at the top of the head, end of the jaw, end of the eyes. In fact, I won't use any of the eye joints in the bind because all they do is control the angle of the eyeballs. But also because I don't want to bind to the dummy joints in the legs or the joint between the last spine joint and the left arm joint, the left shoulder joint and right shoulder joint. And I also don't want to bind to every spine joint either because you can see in my model I don't have that many divisions in the torso, so I have significantly more spine joints than I do edge loops on my model. So I'll bind to every other spine joint, so spine, spine 2, spine 4, and spine 6. So I created a MEL script that selects the joints that I would suggest you use in your bind. So all it does is select the hips joint, every other spine joint, and then every other joint that you want to include in the skinning, but none of the ones that you don't. But as I mentioned with the script that automatically renames the joints in the skeleton to match the human IK template, if you decided to use more or fewer spine joints, you would have to alter this script to either add the spine joints that you want to include in the bind or to remove spine joints that you didn't include in your skeleton. So if you only had 4 spine joints, you would want to remove the spine 6. If you had 8 spine joints, you'd want to add spine 8 before neck here. So I'll just select all the text here and copy it, open my script editor and paste it, and then execute that command. And then I'll shift select my mesh, go to skin, and open up the bind skin option box. And if your character model happens to be made up of multiple objects, mine happens to be one contiguous mesh, but if your character model is made up of separate objects, you would want to select all of those objects after you select the joints that you want to include in the bind and before you bind the skin. And then I'll set my bind to not to joint hierarchy because I'm not binding to the entire skeleton, but to selected joints. I'll keep the closest distance, which will associate the vertices to the joints that are closest to those vertices on the model. I'll choose the dual quaternion skinning method because that produces a better result when the arms and legs are twisted in the upper and lower arm and upper and lower leg. Leave the normalized weight set to interactive, the weight distribution set to distance. Allow multiple bind poses you can leave on. I'm going to suggest you set your max influences to 4, and that determines how many joints can be weighted to any single vertex on your model. For more complex skeleton systems, sometimes that max influence will be set up to 5 or even 6, but 4 will be plenty for our purposes. Leave maintain max influences, remove unused influences, and colorize the skeleton check. Colorize the skeleton will color each joint a different color, and the vertices that are assigned to those joints will reflect those joint colors. And then I'll leave my drop-off rate set to 4.0 as well. And then once you get these set up, it's a good idea to save these settings, because if you have to start over again and you want to rebind your skeleton, if you have to fix some joint placements, for example, this will allow you to not have to worry about resetting these options. You can just save the settings, and they will be saved every time you bind the skin. So I'll click bind skin, and that will bind those selected joints to my mesh. And now the skeleton will deform this model. So if I start posing my model here, you'll see that the skin is being deformed, but it's obviously not perfect because the software is pretty stupid. It doesn't understand that this is a person or that this is an arm or that this is a torso. It's only evaluating how far the vertices are from the joints that are close by to it and assigning them weights based on algorithms that are designed into the software. So I'm going to have to go about painting my skin weights so that it deforms exactly as I want it. And just like almost everything we do in this course, the most important thing is to use your own body as your guide. That will help you figure out how to paint these skin weights so that your model deforms in an anatomically believable way. Okay, before I get started, it's a good idea to select your mesh and then go to your skin menu and first normalize the weights and then prune small weights as well. And that will help to get rid of any really small values that the vertices were assigned to one joint to 0.001 where it should be 0 that sometimes happen when you initially bind the character. So if I were to select any vertex now, I could go to my Windows General Editor's Component Editor, go to my Smooth Skins tab, and you would see that this particular vertex, which happens to be vertex 1083, it's weighted partly to the left arm joint, partly to the left arm roll joint between the shoulder joint and the elbow joint, and then the elbow joint, the left forearm joint. If you added these three numbers up, and I'm not going to bother doing that for you, you can take my word for it, they would add up to 1. And I could select any vertex on the model, and you would see that it's weighted to the joints that are nearby to that particular vertex, and that all of those numbers add up to 1 as well. So I could weight the entire character by changing these values in my component editor, but that's a really inefficient way to go about doing this. So we're really not going to use the component editor at all. But I just wanted to demonstrate to you that the way that I described how skinning works and how it weights the vertices to the joints that are nearby it can be demonstrated by looking at these numbers in the component editor. So we're going to be working strictly with the Paint Skin Weights tool. And you can get to that from the Skin Paint Weights option box. I've also added it as a button on our shelf. And double clicking on this will bring up the tool settings. And you'll see here that all of the joints that I've included in my bind are listed here. Each joint has a button that allows you to lock that influence. Looks like a padlock. When it's gray, it's unlocked, and I don't know if you can see this on the screen, but it looks like an unlocked padlock. If I click it, it will switch to locked and will look like a yellow locked padlock. And this is a really important thing to understand that I think trips up a lot of students. That whenever a joint is unlocked, that means that when you start painting, values can be assigned to any vertex that I paint to any open joint. So it's important to understand that if you don't want to change the weight for any of the joints that you have in the bind, you have to lock those influences. So the process that I'm going to suggest you use to go about this is to first block out the weights by painting every vertex on your model to be weighted to one and only one joint 100%, or a value of 1, so that every vertex on your model will be given a value of 1 or 100% to one and only one joint in the bind. And then you'll unlock 2 or possibly 3 joints at most, leaving all of the other joints in the bind locked, and paint only those open joints in each area. And I think that helps for your first time at least, because it allows you to work on only one area at a time without having to worry about painting weights that you don't want, because those joints will be locked. And you can see here that if I scroll in, if I select any joint in my Paint Skin Weights toolbox here, you can see that there's values that are assigned to it. So if I select the left up leg joint, which is the joint at the hip here, you can see that it's whitest or hottest right around that joint, and then it cools off or gets closer to black as it moves away from that joint. And you can see that's the case for every joint in my bind here. It's whitest near the joint, and then those values fade as it gets farther away. And I could work my way around the entire skeleton, and you would see that. But what I'm going to suggest that you do is you block out the weights by assigning every vertex a value of 1 or 100% to one and only one joint. So the way that I'm going to suggest you do that is first turn off the selection of joints, because in Maya, the selection of objects and nodes, things like joints, models, curves, locators, there's a hierarchy. And joints are at the top of that hierarchy. So if I drag over my model here, obviously I'm dragging over both the model and the joints, but the model isn't selected, only the joint is selected. And that's because joints are higher in that selection hierarchy. So I don't want to select the joints in my skeleton. I only want to select them in that Paint Skin Weights toolbox. So I'm going to turn off the selection of joints here in my Select by Object Type bar by clicking on the button for joints, so that it's not depressed anymore. And that means that when I drag over now, I won't be selecting joints any longer. I'm selecting the model, because the Select Surface Objects button is still depressed, but the joints button is no longer depressed. And that'll make sure that you don't automatically select joints, because that can be a little bit annoying. And that will allow us to select the vertices on the model without accidentally selecting the joints. And I'm going to suggest that you tear off a menu here to make it easier to select these vertices for this blocking out process. So under Select, I'm going to have you tear off the Convert Selection submenu. And you do that by selecting the top of the menu. You'll see these 3 rows of perforated dots. If you click on that, it will tear off the menu so that it's always displayed. And I'll just move it over to my left here. So what I'm going to do is start selecting edge loops and then converting those edge loops to vertices. So I'll start with the hips here. So I'm just going to start selecting some edges here and then converting those to edge loops. So I'll click 2 edge loops in my Convert Selection submenu, get all the ones that I want, and then convert that selection to vertices. Deselect any that I don't want, because I want just the vertices that encompass the pelvis area for the hips. I'll initiate my Paint Skin Weights tool again, and I'll go through this entire blocking out phase with all of the joints unlocked, because if any of the vertices that I select at any given time are weighted to any joints that I don't want, those joints need to be unlocked in order to pull those weights away from those joints. If I locked any joints, I wouldn't be able to change any values that are associated with that particular joint. But I'll select the hips here, and then I'll scroll down here, and I'll set my paint operation to replace, which will replace whatever I have selected at the time with whatever value I set. And I'm going to set my value up all the way to 1. And then I'm going to flood the selection that I have, these vertices. And you'll see that will turn completely white for that hips joint. So what I've done now is I've replaced all of the values for those selected vertices for that hips joint to a value of 1, or 100%. So now what I want to do is select all of the vertices that I don't have selected now, or all of the vertices other than these ones around the pelvis or the hips. So I'll first get out of my Paint Skin Weights tool by hitting Q or Select, right-clicking and choosing Vertex, and then going to Select, Inverse, and that will select all of the vertices that I didn't have selected. So we'll invert that selection. And then I'll go into my Paint Skin Weights tool again, with hips selected still, and with the paint operation still set to replace. I'll set this value now down to 0, and I'll flood these. So what I've done now is I've set the value for all of the vertices that I've selected here and given them a weight of 0 for the hips. And that means that for the hips joint, only those vertices around that pelvis area will be weighted 100% to the hips, and all of the other vertices on the model will be weighted 0 to the hips. So now I'll move on to the spine here. So I'm just going to select these 2 edge loops here, convert them to vertices, go into my Paint Skin Weights tool, go down and find my first spine joint, replace them with 1 and flood, hit Select, right click and choose Vertices, invert my selection, go into my Paint Skin Weights tool again, set my value down to 0, and I still have my spine joint selected, and flood that. So what I've done there is I've set those 2 rows of vertices around the spine 100% to the spine joint, and then all of the other vertices on the model 0 to spine. So then I'll set this edge loop here, convert it to vertices, select my spine 2 joint, flood that with 1, invert my selection, and with that spine 2 joint still selected, set my value down to 0. and flood that. So I'd work my way around the model here and go through this process for every joint that I've included in my bind. And I'll be mirroring these skin weights, and I would suggest you do the same so that you only have to skin one half of the model if you have a symmetrical model. If you don't have a symmetrical model, most likely it's going to be largely symmetrical, so you would want to do the same thing. You would want to paint the weights for only one half of the model and then mirror them over. And if there are any asymmetrical details on one side of the model that don't exist on the other side, you can paint them after you mirror the skin weights, because nearly every character model is largely symmetrical. So I'm only going to worry about doing this for the left side of the model. So I'm just selecting all of the vertices that are just around the chest area. And I really don't have to worry about the ones on the right side because I'll be mirroring those over. Sometimes it'll be easier to just select the edge loops, but sometimes it'll be easier to just deselect the vertices that you had selected previously. So I would continue going around the entire model and blocking out these weights so that every vertex on the model is weighted 100% or 1 to one and only one joint. So now I've gone around and completed that blocking phase so that every area on the left side of the character lines up with the appropriate joint for that area of the model, so that every vertex on the model is weighted 100% or 1 to one and only one joint. So now I can mirror these block weights over to the right side simply by selecting the model, going to my rigging menu set, Skin, open up the Mirror Skin Weights option box, and just like with the mirror joint settings, you're always looking for the mirror across option that doesn't include the axis that you're mirroring across. So again, for me it's the x-axis that I'm mirroring across, so I'll choose the mirror across setting that doesn't include x, so it would be YZ. I'm going left to right, so that's the positive direction to the negative direction. If you had blocked out the weights for the right side of your model and wanted to mirror them across to the right side, you'd want to uncheck this option. So now we can see that the weights have been mirrored over to the right side so that the same blocked out weights exist on the right side that I painted on the left. So this is the first phase of the skin weighting process that I would strongly suggest you go through, because it can be confusing if you go right into painting the weights without blocking them out first, because the software is going to decide which vertices should be weighted to which joints, and that doesn't take into account the anatomical realities of your particular model. So once you've blocked them out, then you're going to lock all of the influences and unlock 2 or possibly 3 at a time and feather and smooth those weights. But before you start this process, you'll need to set some animation on each part of the character as you go around. So I'm going to start by painting the left arm, at least the top half of the left arm, to demonstrate this. So I'm going to set some animation on this to begin. So I already have a keyframe that takes my character from the T stance to the A pose that I needed to skin my model, because my model was in the A pose. So I typically set my start and end to a fairly small range. So I'll set mine from frame 10 to frame 30. And then I'll just set at frame 30 a keyframe by pressing the S key on my keyboard, which is the hotkey in Maya for setting a keyframe on the selected control or joint for the shoulder to start. And that way I can scroll through my timeline as I weight this. So I'll open up my Paint Skin Weights tool again. So the first thing I'm going to do is select all of my joint influences, all the way from hip, hold down Shift, and then select all the way down to the last thumb joint, and then click the lock button to lock all of the influences. And now I'm going to unlock only the ones that I want. So for the left shoulder, it'll be just the spine 6 and the left arm joint to start. And one of the advantages of blocking out the weights like this is that you can get pretty far along now just using the smooth operation. So I'll set my paint operation to smooth. And you can choose different brush profiles. They are exactly as advertised. This one would be no fall off, so the entire diameter of the brush is the same value. This brush choice has a bit more fall off. This has even more. This is a square brush. I typically leave it set to this soft brush rather than the Gaussian brush, because that's a little bit too smooth for me. But I can set this to smooth and start to smooth out these weights until I get the appearance that I want. Now I don't want this to pull so much here, so I'd want to add some weight back to the spine 6 joint. And there are 2 ways to do that. I could choose the add operation and set my value to something low like 0.1 or 0.05, and then select the spine 6 joint. And each time I run the brush over the vertices, it will move a bit closer to that spine 6 joint. And I can also go in the other direction. So I can set my operation to scale, and to do the exact opposite, I would set my value not to 0.05, but to the polar opposite of that, so 0.95. And then if I set this to arm, I'll be doing the exact same thing. So first I added 0.05 to the spine, and now I'm going to be subtracting 0.05 essentially from the left arm. And it's accomplishing the same goal. And those are really the 3 operations that you'll use in this phase of the skin painting, whereas you're using exclusively replace when you're blocking out the weights. Holding down B and dragging the mouse will increase the size of the brush. And once you get a decent result, you can set some further animation. So instead of having the arm rotate up, I'll have it rotate down now. And actually have a pretty decent result already. So I'm going to delete this keyframe. And then I'll set some animation for the twist. And now I'll lock that spine joint again and unlock that roll joint. And sometimes you'll want to select rows of vertices because, particularly for these twisting motions, you're going to be weighting the entire edge loop or the entire row of vertices the same. So I'm going to select some edge loops here, convert them to vertices. And just start adding some small weights again. And I can hit flood, and now I'm adding 0.5 each time I hit flood. Looks pretty good. So now I'll set some animation for the elbow, so I'll delete this keyframe. Now I'll lock the left arm and unlock the elbow joint, the left forearm joint. I'm actually going to unlock the next joint as well, the forearm roll. Just going to select some edge loops, convert them to vertices at times. So sometimes you want to select entire rows of vertices, sometimes you want to paint on the object level. It's going to take some experimentation for you to get used to what adding small weights to one joint versus another will do to the skinning, what scaling from one joint to the other will do to the skinning, and what smoothing will do as well. I'm going to add a bit of animation here to make the elbow bend in the other direction. If you watch your skin, if you observe your own skin, you'll notice that as your elbow bends, it's a fairly sharp angle on the back, so this is actually looking fairly good. And at some point, even though your skin can't penetrate itself, obviously, the skin on the bicep and in the front of the forearm will meet, and this crease will appear that looks pretty close to this. So this is actually looking like a pretty decent result. So this is the basic process after blocking out those weights. You'll go around the rig, set keyframes on each part of the rig, and then paint those areas with the add, scale, and smooth operations. Again, sometimes it's more advantageous to select rows of vertices, while other times it's more advantageous to paint on the object level. But this is the basic idea. So I would continue going around each part of the model and painting the weights until I got a believable result. Now the quality of the character model also plays a role in this. In an ideal world, you would have control over the construction of the character model as well. But if this is your first time skinning a character, chances are it'll be your worst attempt at skinning. Try to get the best results you can, but try to remember that the focus of this course is the animation, and the most important thing is to get to a level where you can animate the character and the skinning will deform the model in a manner that it won't be distracting to that animated performance. Okay, so now I've gone around and finished painting the skin weights to an acceptable degree. Character deforms pretty believably in each area, without too much collapsing in areas like the front of the pelvis where the leg meets the pelvis, with rounding in the butt area. Got a pretty decent result with the jaw, which is often a difficult part of the model to skin because the bottom of the mouth stretches open while the top lips remain relatively static except for the corners stretch down, and then the bottom of the chin has to go into the neck without too much collapsing. So I've got a pretty decent result from that. The head as well. So again, the goal is to get to an acceptable state of deformations on each part of the model so that you can move on to the animation portion of the course. Each time you skin a character, you'll get a little better at it, you'll get a little faster at it, but it does take time. Remember to always use your own body as your guide. That's the best way to figure out how each part of the model should stretch or compress, collapse or expand. And observation is the most important tool for any rigger, or animator for that matter. So give this a shot. Try not to let perfect be the enemy of good enough, and focus on getting an acceptable skinning that will allow you to begin animating your character without the deformations being distracting to the viewer.